Hello, welcome to Now, Next, and Beyond. I'm Jeff Nolan. With me today is Gerald Dahlman. Gerald is the vertical leader for our consumer electronics business, and we're going to have an exciting and interesting conversation about the world of consumer electronics and all of the devices and components that go into them, now, next, and beyond. So with that, welcome, Gerald. A pleasure to have you with us here today. Where are you coming to us from?
So I'm working for Coherent in Switzerland. So I'm located in Zurich. We have a production site here, around 400 people, and but I work in corporate. So I work for corporate marketing. My boss sits in California.
Got it. And I am coming to you from my home base in sunny South Florida, which explains the weird background because I'm in my home office, and we're going to work on that. Gerald, how long have you been with Coherent?
I've been with Coherent for almost 9 years now.
Oh, that's awesome. And in what roles? You have a engineering background, right?
Yeah, that's right. I'm engineer. I have a PhD in electronic engineering. And I started at Coherent 9 years ago as a product line manager. And 5 years ago, I switched over to corporate marketing.
Got it. Are you Swiss nationality?
I'm German. So I grew up in Germany, and I've been living in Switzerland now for 20 years. So feel quite at home here. My family, my kids are born here. So we've been, we have Swiss citizens.
You went to school in Paris and in London. So you are definitely a man of the world.
I've quite traveled a bit in my life and lived and worked in different places. So in France and in the UK, in Germany, in Switzerland now. So it's a typical European biography, I think. People go to different places and live in different places.
Well, it's mobility in Europe is, enhanced by the geography, right? It's like for me to go from, Miami to San Francisco is a 6-hour flight. I think if I left London, flew 6 hours, I'd probably be somewhere in the Middle East.
Exactly. Yeah. Everything is very close here. So
yeah. So tell me a little bit, what's your hometown? You're in Zurich?
I'm in Zurich, exactly.
Yeah. What's your favorite thing to do in Zurich?
So Zurich is very nice. So it's close to the mountains, and we have a nice lake here, and we have a river where you can swim. So it's really a beautiful place in Switzerland.
Favorite time of the year? I mean, you must have some amazing seasons.
So, the winter, we don't get to see the sun very much. So but we have snow in the mountains, so we can go skiing. And usually the summer and the spring is the nicest time of the year, I would say.
What is a traditional Swiss meal? Nobody ever says, I'm going to go out for Swiss food. What's a traditional
Exactly. So Swiss is not like the best place for food. I think the traditional here in Zurich is chocolate and cheese. So chocolate and cheese.
All right, you had me at chocolate. I'm good with that. I can eat chocolate 3 times a day. All right, let's jump right into it. Let's the setup here. So consumer electronics, I think depending on who you're talking to, you're going to get wildly different answers for what is consumer electronics as a market. How do you define the market for consumer electronics?
So the way we define consumer electronics is, personal electronic devices that are used every day and typically in private homes. So things like smartphones and smartwatches and TV sets and audio equipment. So gaming consoles, all this we would count under consumer electronics.
Okay, but automotive is not part of consumer electronics.
Automotive is not part of consumer electronics. So in our definition, it's not so, even though many things are quite similar. Yeah. Okay.
We're going to talk at various points today quite a bit about a technology called VIXEL, vertical cavity surface emitting lasers. Tell us, at a very high level, what is a VIXEL and how does it work?
So a VIXEL is a type of semiconductor laser diode. So it's a laser device. So quite a simple laser device actually. So and the speciality about the VIXEL is that light comes out from the top. So they're also
side emitting
or edge emitting lasers. Exactly. These are the two types of laser diodes. And VIXEL, the specialty is really that light comes out of the top of the surface.
Okay, so it's a semiconductor. You put energy to it, it excites photons, and then they shoot it.
Like any laser, so it has a cavity between two mirrors and some active materials, so some gain material that converts electrons into photons. This is how the laser diode works exactly.
And I don't want to say, oh, this simple device, because I know it's actually incredibly sophisticated, but they're very small, right?
They're extremely small, exactly. So the smallest devices have the lateral dimensions, basically the diameter of the hair. So like 150 microns, something like this, is the smallest VCSEL devices. So little cubes of 150 microns in each direction.
Wow. And how is it that this device, or this component really, became so pervasive? I mean, what were the tipping point?
I think the big advantage of the VCSEL is that you can manufacture it very efficiently. So you can manufacture these on wafers in a wafer scale process, so similar to the way you make semiconductors. And with VCSELs, you can also test them at wafer scale. So you don't need to separate them. You can test them directly on the wafer, and they are also very easy to integrate. So the people that buy them and use them, for them, it's very easy to put them into a system. So I think this is what makes VCSELs really so popular in consumer electronics.
And how many of these are shipped? Like, how many do we ship each year, if we can say that? How many? Well, how big is the market, I guess?
So, I would say that we probably ship a couple of 100 million every year. So this is typically, and over the last 10 years, I would say we have probably shipped something like 2 billion devices overall. So this is, so a huge number. So they're used in consumer electronics, like smartphones, like tablets, like smartwatches, like computer mice. So plenty of applications.
Basically anything that is sensing for presence or movement or,
Correct.
Right. Okay. And so you mentioned wafer. How big are those wafers, and how many VCSELs can be on a wafer?
So the wafers that we use, they are 150 millimeters or 6 inches. And, so that, different VCSELs come in different shapes and sizes. So I would say sometimes we have 10,000 VCSELs on a wafer. Sometimes we have up to 400,000 VCSELs on a wafer. So,
400,000.
These very small devices, we can fit a lot on a single wafer.
All right. So back to the market. Obviously, consumer electronics is a huge market. When you look forward, when you look ahead, how much of market growth do you expect to be driven by existing products moving through their natural product evolution life cycle versus new products that have yet to be delivered or even imagined yet?
Yeah, it's a good question. So I would say right now our market is really, mainly the smartphones. I think the smartphones is by far the biggest market for us, and I expect that it will stay like this for a while. And then you have other devices. You have the tablets and you have the smartwatches I already mentioned. So, and then the emerging device categories, something like smart glasses and VR headsets. So I think the growth in the long term is coming from these devices. In the short term, I think we will be focused on smartphones, and in the longer term, very much on these new device categories or new features in these existing device categories. I think it's both of them.
Yeah, but I mean, it's been widely reported that smartphones are a mature category. It's declining shipments. And, I think a lot of us who are sitting on, iPhones or Galaxy devices or whatever, it's getting harder and harder to find a reason to upgrade them. So how does our manufacturing then flex to meet those demands from a market that is fluctuating not insignificantly quarter over quarter?
Yeah. So I would say that anyway, the smartphone and consumer electronics is very seasonal. So we have, across the year we have variations. So usually, we ship a lot of devices in the summer and in the fall for the Christmas, the Christmas sales. And so this is like a typical pattern. When a new product comes out before Christmas, then we ship a lot, and then it usually slows down. And but we're in steady state. We get these forecasts. It's quite predictable, so it's something that we are very accustomed to by now. So it's
Yeah, I would
quite
imagine our customers are, pretty dialed in to what their demand will be. It doesn't appear, when I look
exactly.
at like
So,
new product introductions, there really isn't much of a shortage factor anymore. It's like we can't produce them fast enough. It's like they really do seem to know how many to make at any given time.
Exactly. So yeah, exactly. Once the product is launched and qualified, then usually we're in steady state and we have good visibility of what we need to ship by when. So I think the struggle is always to get a product qualified in time. I think this is where we really have to stretch ourselves and really make sure that we get ready on time, because a product launch doesn't wait for us. So
Yeah.
we have to be ready in time. That's important.
Yeah. What does that qualification process look like? What are the steps?
I mean, if we make a new design, then yeah, usually we start like a year before the product launches, so that we ship the first samples, and then step by step we improve the performance. We make sure that reliability targets are met, and and every couple of months, I would say, we ship a new generation of samples that are closer to the final product, and then I would say 3 months before it goes into volume production, everything is locked down and then tested. And and then we get the green light and we start to ship.
Okay. And this is I mean, these are semiconductors, so they're chip level. The packaging on them, what is there packaging on these, or are we shipping them basically bare chips?
We ship the bare chips, actually. So
Okay.
we ship them basically on a sticky tape, and and the customer, they pick it from the sticky tape and they put it into a module. This is how it works.
So when we're talking about qualification, then it's performance aspects that we're qualifying. How much energy it uses, what is the output, the response time.
So the correct light output, reliability is very important with VCSEL. So or with lasers in general. So we need to make sure that they last for many years, right? So for all the operating hours that the device is specified for. So this is very important. Yeah, performance, reliability, power consumption obviously is one of the things that we measure.
We're going to talk about product lifecycle and how we work with companies a little bit later. I have a few questions on that, but let's shift gears and talk about new categories. It's been widely reported, the Humane AI and the Rabbit AI devices kind of bombed. Does that concern you? And specifically the difficult hill that new hardware companies have to climb to get a product to market and then to scale. Does that worry you?
It doesn't really have to worry us as a component supplier, I would say. But I think in general, we prefer to work with the established companies, that already have an existing product and a market. So where we have less of a market risk. I think that's important. But of course, we also work on completely new technologies that might or might not be successful.
Right.
So I think we do it all the time. So, and of course, I also saw the Humane AI, and they had I think they had a disappointing product launch, and I think, but it's a new category things, and these companies, they have to take some risk and try out new things, and when we can, we support them, of course, as well.
Yeah, and I don't want to, I don't want to punch down, because obviously they're having a hard time, and nobody wins by beating them on that. But I do think it's interesting, the intersection of AI and these and devices. I mean, we saw a little bit more of that with the latest iPhone launch as well, and I mean, it's kind of taking over everything. It's hard for a company launching a product, especially if it's connected to AI. It's very difficult to control the expectations for that product. Now, in the case of Humane and Rabbit, they also ran headfirst into the laws of physics, right? It's like these things use a lot of energy. Well, you can't walk around with a giant battery strapped to your chest, right? And it's interesting too, because the Vision Pro is a great example of this, and the Quest, where the battery pack's actually separate from the device. It's like they recognize that power is everything. It's like you can't have a device that's you're going to use all day long if it only has 3 hours battery. So actually, that's a good jump to what are the other components that we supply to consumer electronics companies? We just talked about VIXEL. So what else? What are the other things that go into these devices?
So the VIXEL is one, but we also make edge emitters. And in general, when we talk about laser diodes, then we have different wavelengths. So we cover basically the entire infrared spectrum. We started at 800 nanometers and go all the way up to 2.5 micrometers. So this is different laser diode products, VCSELs and edge emitters. Then we have photodiodes, we have optics, we have diffractive optics, we have substrates. We also have illumination modules. So that means that we take optics and VCSEL and put them in a package together and make complete illumination modules. So these are typically the kind of products and components that we offer for the consumer market.
And would those illumination modules be like a sensor pack on the back of an Apple Watch?
So illumination module is something, so we would ship it as a module, and then it gets integrated usually into another module before it gets integrated into the device.
Oh, like a dot projector? Would that be one?
Exactly. Yeah. Dot projector is one example of such a module. Exactly. There are flood illuminators, dot projectors, and other light sources. So different shapes and sizes that we have for these illumination modules.
So in another podcast episode we did with Oliver, we talked about display technology. Your focus is everything that's really behind the display, right?
We also have some components for the display. So, for example, we make substrates that are used for augmented reality, so for smart glasses. So we make substrates that are used to make the eyeglasses. They are waveguides. So this is one application. And but usually most of the components that we sell are for sensing. So they are basically generating data for these devices to become smarter, right? To understand the world, to understand context, to understand what's happening around the user. That's most of our products are related to sensing.
Okay. Well, and on that point, going back to AI, if we make an assumption that AI chips will work into consumer electronics at all levels, those systems are going to have a voracious appetite for data, and the data will come from sensors.
Correct. Exactly. Yeah. So there are cameras, there are microphones, and there are other kinds of sensors. So we are mainly involved in 3D sensing or depth sensing. So that's an important category that we supply. And but there are also other sensors like chemical or biological or environmental sensors. So all different kind of sensors, and they generate data, and AI is used to understand and interpret the data. That's very exciting.
Personal health sensors, another one. Yeah,
exactly. For example, personal health sensors is one category that we also work on. Yeah.
Okay, so we have AI in the smartphone, in the watch, in all of the other devices that we're carrying. We have this whole array of sensors that are feeding it data, feeding the system's data. Does this fundamentally change the architecture of consumer devices as we know them today? The ability to capture, store, process, and transfer information coming from a sensor pack?
So I think one trend that we can talk about is really that these devices are getting more and more sensors because they become more and more useful at understanding context, at understanding language, at understanding images, and understanding basically the world as we as humans experience it. So that's one trend. And then the second trend is really that that AI is used and machine learning algorithms are used to interpret the data to make sense of it, so that computers not just see the world, but they understand it. They understand what is going on. So, and I think, from an architecture point of view for these devices, I think the big question nowadays is, will everything be sent into the cloud, or will the data be processed on the device? And I think there are different opinions on that. Personally, I think that it would be much better if it could be processed directly on the device, so on the edge of the cloud. And one reason is that this is a lot faster, so you don't have the latency, right? It's almost immediate. And the second reason for me is also privacy, because we don't want all our personal data to go in the cloud and to be visible to God knows who, right? So this is one concern. So I think, the data, the more can be processed in the device and, in private mode, the more acceptable it will be to users, I think.
Yeah, and that was a consistent criticism of the Humane, I guess, and the Rabbit devices too, was the latency really killed the usability of it. But I think we can also, reasonably say that as you move beyond 5G, that the wireless technologies will continue to, double, triple, quadruple bandwidth in ways that we can't even really fully imagine today or appreciate today. So it could end up being a hybrid model.
Constant trend, right? So the bandwidth increases, but I think about these future networks, also what is important that they get the latency down for this kind of real-time applications. I think that's another key for networks of the future, that the latency comes down.
Yeah. Well, and also I think the network architecture itself will have to be more tightly bound to the software architecture, so that you're transmitting or you're pushing data incrementally based off what you need, right? And then you're using the low cycles to then complete that packet transfer when you don't need it. So I think we could see a pretty big change in network architecture as a result of this. What about laptops and desktops? I mean, we talk a lot about consumer electronics really being the devices, we hold in our hand. But what about the ones that are sitting on my desk right now that that don't really move, even though a laptop is portable? I think most of us don't really take our laptops and use them as portable devices anymore.
Yeah, I would say some innovation happening also in laptops, but I would really say that it's not the most dynamic platform consumer electronics category for innovation, right? So, I mean, laptops have been around for so long, and and I think now, AI is coming to PCs, but I don't see a lot of sensors coming to PCs. So maybe, facial recognition that could come to PCs, and maybe also, I mean, obviously we have cameras and microphones already, but beyond that, also one reason is that, the laptop, it just sits on your desk. So it looks at you, but at nothing else, right? So I think for sensors, the devices that we carry around with us, they are a lot more interesting. So I think as a platform, so we see more sensing applications in smart glasses and watches and things like this.
Yeah, well, I think I agree with you actually, because, and I have to give Apple credit here, because for all of the times that I've heard people say, God, if a MacBook Pro just had a touchscreen, it would be so much better. But, Apple has been really disciplined about touch computing and desktop computing being in their separate swim lanes. And, the experience on an iPhone versus a MacBook or desktop is fundamentally different. And it's even different when you're on a mobile device doing something that requires a file system. You realize the shortcomings of a mobile device for desktop style work. But it does seem like these devices are pretty primed for an explosion in sensor capabilities. You just talked about biometrics and cameras, right? So we already have Touch ID, or the equivalent of Touch ID. Cameras are pretty sophisticated in these devices now, in these laptops now. But what about and of course, microphones and the entire sub-assembly that controls sound is increasingly sophisticated. What about environmental sensors, or being essentially a dock for your personal health sensor, or security, or anything for that matter? I mean, it seems like it's the perfect HomePod, to borrow an Apple term.
Yeah, I think all of the above. I think environmental sensing and chemical sensing, biological sensing, I think that's all areas where we see a lot of innovation happening, and they're very exciting for us.
And what do our customers ask for? So when our customers are looking beyond current generation, what are they sharing with us about where they want to go, without obviously revealing any names or confidential information?
So, I mean, so usually we don't get a lot of information from these customers, because they are usually quite competitive, quite secretive. So they don't tell us in detail what they're working on. So we usually get to see specification. So basically, on a need-to-know basis, we get informed about the spec parameters that we need to know to make a device for them. And then typically it's a very close collaboration. Sometimes we just make a new design on an existing technology platform that can be quite quick, takes 6 months or a year to go into production. And other times we develop really completely new platforms. So, I mean, lasers that have a different wavelength or completely different architecture. So these things, can be a lot more time consuming. So sometimes we start to, work 2, 3, even 5 years before something goes into production. We start working on these technologies together with our customers. So it's a very intimate relationship that we have. So our experts and the customer experts, they work together over many months, sometimes over many years, in order to get such a product to maturity and into the market.
And we supply components to really all of the major manufacturers. So do we have product teams that are dedicated to manufacturer or customer A versus B, and they don't ever talk to each other, kind of a thing?
Yeah, I think some customers require that kind of separation, right? Yeah. So that you have teams that are just working on one customer, so that there's no leakage of IP and confidential information between different customers. So we are very disciplined in that respect, of course.
So we talked about how VCSELs work, sensors work. Not in detail, though, but that by itself is probably a whole other podcast because there's so much going on there. But when we talk about sensors as a category, yet they do different things, are there subcategories, some of which you already mentioned, but are there additional subcategories that we manage either from a product portfolio or market demand standpoint?
So I would say one category that is very important for us is the depth sensors or 3D sensors, right? Yeah. So this is basically making a 3D map of the environment so that you can understand not just the flat image of the world, but also where objects and people are located in 3D. So really making sense of the 3D space. So that's one category where photonic sensing, what we do, is very important. So, and we support different sensor architectures. So there are depth sensors based on time of flight. So that's a measurement of, you send a light pulse and you measure the time until the light comes back to the sensor. And there are other ones based on structured light. So you project a pattern into the scene and you look at the deformation of the pattern when observed from a different angle. So there are different architectures of these depth sensors that we support. And and then another category is environmental or biosensors. So this is really about sensing, chemicals, sensing molecules. This is also done optically with light. So let's talk about a biosensor. For example, you can shine light into the skin, and then under your skin you have blood vessels, and light gets reflected differently depending on how much blood is in the blood vessels. So, and for example, every heartbeat you have a different reflection pattern, and if you count these, then you can measure heartbeat. So that's one example of a photonic sensor that is used, or blood oxygen sensors, and future sensors will maybe be able to measure glucose, for example. So glucose through the skin.
Non-invasive.
Non-invasive, exactly.
Yeah. So these sensors are really kind of like the Swiss Army knives of components.
A bit like this, yeah. I think sensors, are very versatile. We can measure a lot of different things, and they get more and more powerful.
And as a resident of Switzerland, do you ever get tired of people saying the Swiss Army knife of fill in the blank?
I think, Jeff, you're actually the only one that uses that metaphor. So
I coined that. All right.
I can handle it once in a while. No problem.
All right. Yeah. So on depth sensing, Face ID on an iPhone or any depth sensing, how many dots are being projected?
Tens of thousands, I would say. That's typical. So, yeah.
And in order for that to work, in addition to projecting the dot, there needs to be a receiver to capture the data that's reflected back.
Correct. There's an infrared camera that detects the dot pattern and measures the distance between the different dots. and that is then decoded. That information is decoded to generate the 3D map or the depth map of the scene.
What's the response time from the projection to the detection to the decoding?
It's video frame rates, so they can do this at 50 frames a second, and even faster if they want to. So I think
it's remarkable how fast it's gotten over the years.
It's remarkable. Yeah.
And
but
how,
it's relatively.
Remember the early generations, you have to look right into it, and now you can just be kind of off to the side. It could be, it's so advanced now.
It's seamless, right? It's completely seamless. Yeah, it's a very nice technology. I agree.
Yeah. Product lifecycle. Let's change subject. Product life cycles. So you alluded to this early on. A company will come to us. They'll give us questionnaire requirements. And basically, the question is can you do this, right? And that can be up to years, 5 years, I think you said, right? What is the typical lead time for a component that we are shipping for an OEM from the concept to the design to the qualification to production?
Yeah, it really depends, I would say. So we have different customers and different requirements that we are confronted with. So, sometimes we have products basically that already exist, so we can just sell them off the shelf. So and this is very straightforward, very easy. So basically we can ship within weeks. We can ship significant quantities.
Mm-hmm.
Other examples where we have an existing technology platform and customer wants a new design. So, and then the typical lead time is to get, let's say 3 months for first samples. And then we can, depending what we need to do in reliability testing. So we might be able to ship after 6, 9, 12 months, something like this. So this is typical lead time for a new design. And then you have the new technology platform. So if we invent something completely new, something that we haven't done before, then the lead time is usually 2 years plus, I would say.
And in our communications markets, those new technology platforms often go through a standards process to establish a standard that the rest of the industry will adhere to. Is it the same here?
No, actually, we don't have a lot of standards. One standard that we have to meet is eye safety.
Yeah.
But that's usually not done at the chip level. So we supply the chips, and eye safety is something that you have to test on the system level. So, but our customers have to do that. But otherwise, there's not a lot of standardization actually for consumer electronics. So everyone does their own thing, and typically we have every customer we have a different design. So that's how the world works today.
Who volunteers for eye safety?
I think it's nobody has to volunteer. So I think there are tests where they can do it without putting people in danger.
So speaking of, eye safety is a good segue, actually. AR, VR. It's such a fascinating category because it's every year it's the year of AR, but yet we don't ever say which year it is. It's just every year becomes the year of AR. But yet, you cannot ignore the progress that's been made from those early generation. You remember the super bulky, the complete headsets. It's almost like putting on Luke Skywalker's helmet. To now we have goggles, immersive experience goggles. And I learned from Oliver that the transparent, like the Vision Pro, isn't actually transparent. It's projecting an image inside of the headset that's being captured from the cameras, and it makes you think you're seeing through it, but it's really not.
Exactly.
Which I thought, wow, that was cool. To the Ray-Bans, the Meta Ray-Bans have been wildly popular, and they seem like a really great package. So do you think that are we at a tipping point where these goggles and glasses really become a mainstream AR VR experience?
I think so. So it's still hard to predict, if it's this year or next year or in 2 years the takeoff. But I think there's so much investment in this space and really exciting new products and a lot of progress. So I think it's really just a matter of time. And the Ray-Bans is a good example. So I think they have quite a bit of success already in the market with what they have today. But the next step is now that they will add a display so that you can display information, that you can display images. So usually contextual information. So it will make these glasses a lot smarter. So think of use cases like maps, for example. So you will have maps instead of taking your phone out of the pocket, you will get that directly onto your glasses, and so we'll make it very seamless in order to navigate to the destination you want to go. And or online translation, for example. So this is also something that. So imagine you're in a foreign country and you want to suddenly you can read all the signage because you get the subtitles, right? Or you can get online translation. You can get translation in real time. So someone talks to you in Chinese and you get real time subtitles. So this kind of application, I think, is unique for these smart glasses and very compelling use case, I think. So I think really it's a matter of time now until these devices will get traction in the market.
I can't help but think that really this will just be a way for my kids to sit there looking straight at me while being on their phone the entire time.
I think that's the way it is. Yeah.
So when you look at the Ray-Bans are a good one. Let's just say glasses in general, because actually I don't know much about the architecture of the Ray-Bans. But when you look at it from your professional seat, what are the trade-offs that these companies are making from a design and engineering standpoint to deliver the glasses experience versus the goggles?
So I think what Meta is doing with the Ray-Bans is that they want the perfect form factor. So they're not deviating from the Ray-Ban form factor. So it really looks like a pair of glasses, and they're gradually adding now the technology. So first was microphone and the cameras, and now they're gradually adding more features. Like I think so the display is the obvious one that will come next, and then also they will add sensors for eye tracking and sensors for maybe hand tracking for gesture interaction. And eventually it will be sensors for, to overlay objects into the real world. So really to understand the 3D space, and so depth sensors will become a key. So I think it will evolve and get more and more features while staying in this very compact and light form factor. I think this is really the philosophy behind it, that everything has to stay in this form factor. And
So we both wear glasses. I can't really read anything now at my age. I can't read anything without my glasses on. Do you think that these glasses, in addition to providing enhanced features, could also be used for vision correction?
Of course, yeah. So that problem has been solved already. So it's so that can be done. So so display and vision correction at the same time. This is definitely something that is possible already.
What's the power consumption requirements for these glasses?
So I mean, very simple. The less, the better. So I think there's no firm requirement. So, but obviously, if you have to carry a large battery in your pocket and have a cable that goes to the glasses, that's less compelling, right? So, and they want to avoid that. So I think everything in these devices is really about the form factor and about power consumption and about lightweight. So I think this is what makes the engineering so difficult and challenging.
Yeah, and so that actually is my next question: is the constraints are much more extreme here, and does that alter the way that we work with our customers who are building these devices? Because with smartphones and the other devices, it's like they give us requirements, we meet them, we qualify them, and we go into production. But here it feels like we actually have to go beyond that, because we have, as they say, inches or millimeters matter here. We have to go to the extremes from our own product design in order to meet those requirements that a customer might have.
Exactly. Yeah. So everything has to be smaller and lower power consumption for these use cases in smart glasses, right? So this is really important. You cannot just take a module from the smartphone and put it into smart glass, because it's just consuming too much power and also too big. So this is really something that goes beyond what is available today. So I would say that in these bigger headsets, something like the Meta Quest or the Vision Pro, so there you have sensors that are pretty similar to what you have in a smartphone today. But these smart glasses, they have to be everything has to be a lot smaller again. Yeah.
Have you tried the Ray-Ban glasses?
I have. Yeah.
Do you like them?
I like them. Yeah. I like them. So I haven't bought them, but I've tried them, and I think it's cool. So I mean, the display is missing, right? So, but But I've also tried some displays. So not from Ray-Ban, but I have tried some displays. So these parts are now coming together. I think this is what I expect to be announced later this year or early next year, maybe. So that they will have the first of these smart glasses that have real displays from Ray-Ban and other vendors.
Yeah, I think my children have the Quest device that they use, and they like it. It's not an obsessive thing. They don't use it all the time though, which I found kind of interesting. But for me, I think the glasses would be that's the slippery slope for me to get on. The gateway drug for me would be the glasses.
I agree. The glasses in terms of form factor, and if you have a Quest, and I have one too, so if you wear it for a couple of hours, really you feel the weight, you feel the eye strain. So it's really something that you can't use every day for many hours. So it's not made for this, I would say, today. And everybody agrees, right, that the form factor and the convenience and the comfort of these devices has to improve. So, and the smart glasses, they will be like this from the very beginning. So I think, and I agree. This is also what makes them a lot more attractive and the market potential much bigger actually for these smart glasses, because they will be, a lot more comfortable, a lot more fashionable as well. And so people will more readily adopt them and buy them.
Do you foresee any additional form factors? Because I mean, right now the AR VR world is pretty much split between the goggles and the glasses. Do you see a third, fourth?
Well, there's some things in between. So, for example, if you look at the Magic Leap, I don't know if you know the device. The Magic Leap is somewhere in between. Also, I would say that the Microsoft HoloLens, that's a device that is somewhere between a headset and smart glasses. So I think there are these kind of devices in between. But ultimately, I think the ultimate goal is to get everything in this glass form factor. But we might be 10, 15 years away from that still. So until you have a high quality display with photorealistic rendering in this kind of form factor, that is extremely difficult still, and that might take many years.
I'm glad you mentioned the HoloLens. I haven't actually thought about that in a while, but the intersection with the gaming console market, obviously, I mean, the console market, which we haven't even talked about here, is a huge market on its own. You, at the very top of our talk, you did mention consoles as one of the devices. Do you see a drive to this integration of these devices into the console world, kind of like what HoloLens did?
So Sony has a device on the market actually. So it's called the PlayStation VR. So they have a headset that goes together with a PlayStation, and you can play games in virtual worlds, and also the Meta Quest. So for the Meta Quest, there are a lot of games available. So this is, I think now if you look at it, at the market, quite frankly speaking, today it's mainly driven by gaming still. So there aren't so many other use cases, I think, for these VR headsets, where you're completely separated from the world. The main use case today is still gaming. So, and that's how I expect it to remain for the next couple of years. So,
let's talk about life sciences. Bioinstrumentation, bioanalytics, pretty far-ranging term. You already talked about some of these in these different capabilities. Let me just run them off to you. So, blood pressure, glucose,
exactly,
sleep monitoring. Okay, so there's blood pressure, heart rate, cardio and heart rate, oxygen sensing.
Yep, correct. Okay. So some of them are already state of the art today. So some of them you have already in every smartwatch. So heart rate is very standard today, right? And so and that's a photonic sensor. So you shine light in the body, and you measure the variation in blood flow in your vessels. And then you have these other devices that are more advanced, and glucose probably is the most challenging, the most difficult, but also the most interesting, I think, in terms of capabilities that will be added to the smartwatch.
Well, the ability to impact, impact the population of people with diabetes in a non-invasive way. I mean, talk about positive, the positive benefits on humanity. That's a huge one.
Exactly. Yeah. I see it the same way. So I think, if you know what glucose monitoring means today, so the old technology is the finger pricking, right? So you take a blood sample every time and you put it in the machine to do the analysis. And the newer generation, the continuous monitors, they still have a needle. So you have a patch that you put on your arm for 2 weeks, but it's still a needle that goes under the skin. So also that is, it can get infected. It's a little bit painful, at least uncomfortable. And so imagine if you could have that in a smartwatch on your wrist and monitor continuously. So I think it would be a huge improvement.
Yeah.
And, not just comfort, but also cost. I think, these test strips, they're very expensive. The patches are very expensive. So I think these
they're all FDA certified
glucose monitors, they could be quite inexpensive actually. So, and there would be no recurring costs. So you just pay once and then you have a sensor, for many years.
Yeah. Well, the regulatory burden in terms of the cost profile for anything that, has to be FDA certified and inspected, strips, needles, anything injectable, that drives the cost basis, which gets passed on to consumers.
Exactly. And and if you don't need needles, then the burden goes down. So I think this is potentially extremely impactful if people can get that to work. I think it's a great thing. Yeah.
What about environmental sensors for personal health monitoring? Let's say, for example, you have an acute allergy to grass, and it's like you're in you're outside. Could your watch fire up and say, "Hey, listen, there's a lot of grass pollen right now. Maybe you should go inside." Is that?
I think something like this is possible, exactly like a pollen sensor. So I think people are working on this kind of concept. So not something that is available on the market today, but definitely something that people are looking into. So there's innovation in this space. So what you have today is, for example, air quality sensors. So look at CO2 concentration, for example. So if you was a big topic during the COVID pandemic, right? So people use the CO2 sensors in order to decide, when I need to open the windows and get fresh air. So I think this is one topic that the CO2 sensor, that's something that is also optical. Another topic is dust, right? So you have dust particles in the air. So we make illumination, we make light sources that are used in particle sensors, so that measure the dust concentration in air. So there are plenty of use cases already today and more coming. And I agree, also measuring toxic gases, for example, and that's another one that you could do with photonic sensors. So extremely interesting, extremely impactful, I think, in the medium term.
Well, I tell you, I would love something that insect bites. They don't really bother me too much, but we have fire ants, and if I get bit by a fire ant, honestly, the reaction I have to that is beyond painful. That's one I would like. Bee stings, everything else, I don't have an anaphylactic reaction to those, but fire ants I do. That's another one. And I know a lot of other, and there's obviously people who suffer from potentially life-threatening anaphylactic reactions from bee stings and other insect bites. Preventative medicine. This has been another personalized preventative medicine, right? So sensors are good at capturing data. What are the obstacles to taking that data and getting it to the right place, and then doing something actionable and using it for betterment of personal health?
Well, I think, different obstacles, I would say. So the first one, of course, is the data acquisition. So you have to acquire the data and it has to be precise and accurate and reliable, right? So that's the first part. That's the part also that we are involved with, right? As a component manufacturer for these sensors. And then I think the second step is really making sense of the data so that the raw data, that you can interpret it and get the correlation between something that you measure inside the body and a vital sign or a concentration of a chemical. So I think this is where AI and machine learning comes into play. And then it's also, collecting lots of data from different people and making sense of the data for the entire population. So I think, the challenges are at different levels and at different obstacles. Privacy is a big one, obviously, right? We don't want our health data to be available to everyone, but at the same time, if it can be used to improve our health and help us, stay healthy, then it's a good thing.
When I was thinking about this, because we have across the globe, we have an aging population, and not just in developed countries, but really seeing this everywhere. If you've cared for anyone who's elderly, one of the biggest challenges is getting them to a care facility, a doctor's appointment, whatever. I mean, that becomes an obstacle to good quality healthcare is accessibility. I think the personal health sensing, monitoring, data collection, and then actionability on that data coupled with telemedicine and other remote care could actually be a pretty significant leap forward for us as a aging population.
I agree. Yeah. I think this is extremely a very interesting field, and technology would play an increasingly important role in solving these issues and improving people's healthcare. Yeah.
So speaking of aging population or declining population, robotics. I mean, so right now we have simple robotics, but if you look at like what Tesla's doing with their humanoids and other Boston Robotics, I mean, there's some pretty sophisticated robotics out there that are good, not just at doing 1, 2, 3 specific tasks that are well defined, but really working in the world around us. It's very dynamic. That's all enabled by sensors, right? I mean, the ability to replicate vision, hearing, touch, even taste, smell. I mean, all of these things come together in a robotics platform.
Correct. Exactly. In order to make robots interact with the world and interact with people, they need to have these sensory abilities similar to the ones that we have. So this is why robots are really machines that are full of sensors. So they have plenty of sensors for all the things that you mentioned. So
what are some of the most exciting things that you've seen in that market, from your perspective?
So I've also seen these amazing demos of humanoid robots. So robots that look like people and that can walk up the stairs and make saltos and things like this, and they can keep equilibrium in very difficult conditions, and so and also in terms of what they can do with their hands and grab objects and manipulate objects. I think it's the progress is really amazing. But we still have to be honest about this. It's just demos right now. So these are not products that you can go out and buy. So it's really just demos. And I suspect that this is quite a long way still until they hit the market and they are useful and they are affordable. That they really have a compelling value proposition for end customers like us. So I think that's going to take a few years.
So you mentioned one capability that's particularly fascinating is their ability to touch, right? To pick up objects or manipulate objects. What is a sensor? Is it a pressure sensor? I mean, how does that work? You're building a robotic hand. How do you measure dexterity, or how do you sense for dexterity?
I think one key metric, of course, is the position. So you need to know where the different articulations of the robot are. So, and the second thing is that you need the tactile sensing. That's a force sensor, I would say. So pressure or a force sensor that you use in order to measure, the gripping force, for example, of when a robot picks something up.
Yeah.
So it's many different sensors coming together actually in robots. So tactile is force sensing, pressure sensing, and position sensing, I would say.
So we and I actually dove into this world because we live on a farm and we have livestock. It's very common in farms to have livestock protection dogs, guardian dogs, and we need one. But I was looking at, could we just buy a robotic dog to do livestock protection? Because, they can sense, alert, sound an alarm, basically scare off predators. And these things do exist, but to your point, they're really expensive. They're, $20,000 plus for a robotic dog that'll, walk a perimeter. It's crazy. Now, when we move inside the home, though, a lot of the robotics inside the home, or smart appliances, which are another version of robotics, those are much more accessible. And let's talk about the smart home. So we just built a new house and we put a lot of smart stuff inside. We didn't do for the full home automation. We just kind of picked and choose and different things. So let me run down a couple of categories here and you tell me what's unique about them. Thermostats.
So thermostats basically, they understand your regular daily patterns. So I think so they know when you're in the house, they know when you're out of the house, so they can switch on the air conditioning or the heating or the ventilation. Depending on whether you are there or not there, right? So
motion sensing, environmental sensing.
Yeah. So air quality sensing, we already talked about. Right. So that's an obvious one that you would like to have in a thermostat or in air purifier or in an air conditioning unit, right? So, and presence sensing is always important for all these devices. So they want to know, also to switch on and off the lights, for example. So this is done by presence sensing. So this is another one. So smart home is mainly about sensing people and also sensing the environment. Yep.
Security cameras.
Same thing. So basically, you want to trigger the camera when something is happening, right? So you don't want the security camera to get triggered when there's just a cat moving around. So you want to be more intelligent. You want to detect, if this is a human or something that could break into your home. So then you want the security camera to be activated and not when a cat is moving around your house.
But also facial detection, because a lot of the advanced cameras now, like when my 20-year-old comes home at 3 a.m, I don't want an alert coming because somebody came to the door. So facial detection is a pretty big thing in these cameras now too. So again, dot projection and then the software necessary for
Exactly. Yeah. So some of these electronic door locks, they have facial recognition. So I think it's a bit problematic again for privacy, right? So people don't want facial recognition everywhere. So I think this is something that maybe gets not accepted by everyone. But the technology is available, and you can buy these door locks that recognize who is there.
Door locks.
Yeah, exactly. Biometric. The door locks that we just talked about. Yeah. So you have door locks with facial recognition or with fingerprints and biometric sensors.
Robotic vacuums. I actually bought one and did a lot of read a lot of reviews, was on Reddit. We picked one that it was not inexpensive, but it wasn't crazy. And it's actually become one of my favorite devices. But at the same time, even for as advanced as it is, I'm still struck by how primitive it is in terms of its movements. So that has
I have an old one. So mine just bounces from furniture piece to furniture piece, right? So and they just turn around if they hit an obstacle.
Yeah.
And I think they got better, right? But still a long way to go. So but also cost and energy consumption is also very important for these. So I think not everything that is technically feasible is also affordable, and this basically also limits, I think, how smart these sensors or how smart these robots are today. So I think,
What about other home appliances, like kitchen appliances? Do you see sensors playing a role there beyond the usual temperature?
I think eventually we will have robots that will be capable of doing anything. So I think things like folding the laundry, for example, or putting things in the dishwasher, and or setting the table. So I think these are tasks today that are within reach. So I think, robots are getting there. So I think now the challenge is really to make them easy to use and affordable. And so I think, until we see the products in the market, that everybody can afford, I think it will take time. So I don't expect, but the progress is amazing. And, if you see these demos and what they are capable of doing, and I really think we're getting there. So I think
well, I think on the battery consumption, the energy consumption is the big one too. I mean, I always hear the little vacuum. Always, I'm going back to charge now. Battery, going back to charge. But it's like you don't really mind it so much because it's on its own schedule. I don't have to monitor it. But you think about it too. I mean, it's driving sensors, communication. It's driving the mobility, and then it's of course driving the vacuum and the mop functions at the same time. So looking forward. In the home, well, let's say we already touched on it, right? We could end up with homes that are full of these purpose-specific robots that do different things for us. They're like, our, unpaid help, basically. Set the table, load the dishwasher, wash the dishes, clean up, fold the laundry, pick up the laundry.
You don't want to have 10 different robots for this, right? So
yeah.
I think they will have to converge eventually into one device. So like a person, right? Like
that'll
a person.
Tesla's in 10 years, it'll be the humanoid. We'll all get humanoids. It'll be like in the movie iRobot.
I don't think it's 10 years, but I'm just looking at other things, how long they take. So I don't think it's 10 years, but who knows?
Last question. What are some, what gets you excited about the next 2, 3, 5 years? Like, what are the categories of devices that we should be seeing major upgrades in?
So I think, many of the things that we talked about today. So starting with the smart glasses, getting displays and, the use cases that we talked about, maps and translation, for example. So I think this is really exciting. And the other one really for me is glucose monitoring. So if we can get that to work, it would be really, really exciting. So I think these are the things that, that motivate me to do my job well and together with my colleagues.
Gerald, it's been such a pleasure talking with you today. I appreciate you joining us this afternoon, your time. And I learned so much from this. So thank you and have a great rest of your day.
Now Next and Beyond is hosted by Jeff Nolan, produced by Carly Berghoff, and presented by Coherent.